So let's start now talking about continuous integration. What is continuous integration? From where did it start? And where does it fit in the software development life cycle? So first of all, if we are going to look about this image, this talks about some processes that a code goes into before it go into release. So it starts from the Git source control system, GitHub that have a repository, unit tests that will run against your code, and code analysis, test coverage. Then it would go into release. If I saw that picture when I was starting learning about continuous integration, I wouldn't understand anything about it. So let's just move this away and start explaining this with an example. Continuous integration is a process, and if we look into the term process in language, it means it is a series of steps taken to achieve a particular end or goal. So this is what continuous integration. It's not a tool or a technology. It's a process with multiple practices. So let's start with an example. Here we have three developers, and they are connected to a repository. For example, on GitHub, they have cloned the repository and they are working on a single branch, which is the main branch. And now we have the first developer have pushed a change after a week, and the other developers doesn't know about that because this example is talking about the old way, old fashion of implementing and developing softwares. So after 2 weeks, we have David and Jackson. They pushed changes into the repository, and what they face is they will face a conflict. Conflict happens when two developers are changing and modifying on the same block of code or line of code. Or for example, we have David have added a file called main.py, and then Jackson have added another main.py with another content, then a conflict would happen. Or if they're existing a file called server.py and Jackson renamed it into main.py, this will cause a conflict. So any changes that two developers are not aware of, it would cause a conflict. So now if we move forward with this, we would go into another example of how the continuous integration happened and emerged into DevOps. So let's now move forward with our developers. So continuous integration started from a concept which is called integration branch, and this is used to save us from something called integration hell or merge hell. So this happens when frequent merges or releases are happening from the developers into the repository, and they are saving their work on their local machine and not pushing it frequently. So the continuous integration process encourages us to make small and frequent release. And if we Google and search this term on Wikipedia, we would see this page. So if we look up the term continuous integration on Wikipedia, we would find that it's a practice of integrating source code changes. Also, it's a frequent, so you should push your changes frequently and you should release them from your machine into the build server or to the repository frequently. If we go down there, we would find a section talking about committing changes. It's saying here that when we start working on a project, when multiple developers start working on a project, they will take a copy of the main branch or the current branch, the stable code. They will make their changes and then merge all of those changes together. The longer they take to merge their changes and pushes their changes to the integration branch or to the main branch, the greater risk of multiple integration conflicts would happen. It is happening because the copy they took from the main branch are getting diverged from the latest version. So each one of them is making their changes and merging it after a while. And this would cause a conflict if the time between taking a copy from the branch and merging it was long. The risk of having a conflict would be greater. So, and this is called in the industry merge hill or integration hill. And this is when we say integration hill or merge hill, it means that the time that it takes to fix the conflicts are greater than the time we took to make the changes. And this is actually a lot. So here we have our developers, David Jackson, and our anonymous developer. We didn't give him a name yet. So let's now start with what we have. We have a master branch, and the developers will follow the integration branch strategy. So each of the developer will make a clone of the main branch, master branch, start making their changes, check out to the integration branch. It's not a must that they check out into the same branch. Each one of them would be working on a different feature. So they would now, so here, as we said, each developer take a clone of the master branch, and they would work on different features. So developer one would work on a branch called integration dash feature service one. The second one would work on a branch called integration forward slash feature two service something. It depends on the use case and the application itself. So now let's take them now aside, and we have the first two developers. They will push their changes into the repository. They will trigger what we call a build server. In our use case, build server is the Jenkins server, and this will trigger a series of tasks. What we called a process. Process is a series of steps or tasks to achieve an end goal. So here we have install dependencies. This will install whatever dependencies the code is using. For example, for Python, it would be pip install. For Golang, it would be go get. For Java, it would be Maven install. And it depends on the use cases and the programming language. It will build the code, it will compile basically the code and see if there's any compilation error that will occur. Then we would have some tests. Those tests, the developer define, it's either a unit test or integration test. The most straightforward and simple test we have would be a unit test that will run against the artifact, the buildable code. After we build the code, we will run it and run those tests against it. And if those now succeed or fail, this is the responsibility of the build server to notify the developers. So we have them here, and they will take their messages, which would be build best. So there is no merge conflict, there is no errors in their code, and everything is running successfully here as defined in the compiled code and in the unit test. So let's now start with the concept of pipeline. A pipeline is borrowed from the real world, where we have series of pipes connecting a source to a destination. These pipes might carry water, gas, or other materials flowing from one point to another. In our technical context, the source represents the developer's machine, which contains the latest code, or a remote repository that serves as a single source of truth for our application code. It could be something like GitHub, Bitbucket, Azure DevOps repo, or other types of repositories. The destination in this case would be our servers that host our application, preparing it to be consumed by users. And instead of water flowing in our pipelines, it would be our code that is being delivered from development into deployment. So, like in the real world, pipelines consist of multiple pipes. Each pipe presents a stage or a job that has to be done at a specific time in a sequential order. So maybe in our case, we would have the first stage as to be building the code. This stage will consist of multiple jobs or steps in order to reach to the final destination, which is to build the code. To finish the build stage, a series of steps needs to be done, which could be installing dependencies, building the code. Another stage would be is to test the code, and this will consist of multiple steps depending on our requirements. So after all of those stages are done, we will deploy our application into our production servers, making it ready to be consumed by end users. So now let's move on to the sample project part of the course. We will have a Next.js application, which is a front-end application. We will use it to implement our continuous integration, continuous delivery practices. We will implement the stages to run against this project. It would be a very simple and basic project, which is automatically generated by Next.js within some commands. So let's start now and move to the terminal. Okay, I have now created a sample directory, which is an empty directory, and I will start initiating the commands that I need to create the sample application. The commands that we need, that we are using right now, you can find them in the GitHub repository link in the subscription, and I will be copy and pasting the commands from the sample project commands file in the repo we have. So first of all, make sure to have a Node.js npm installed on your machine, and after installing it, depends on your machine with it, whether it's macOS, whether it's Windows, Ubuntu, make sure you have it. So after that, you will start with running npx create next application and the name of your application. Keep just hitting enter to choose the default configuration. After this command succeed, just navigate to your application, see the my next application. You can find here all the setup and routes that Next.js have created for us. After that, run npm install, which will install all the dependencies listed in package.json file. And after that, to run the server, you need to run npm run dev. And now you can find the server running on localhost port 3000. Copy the URL and navigate to your browser. So basically, you can navigate to your browser, hit localhost 3000, and you will find the sample Next.js application running here. We won't need something very complex to implement our practices. We will just change maybe the background, see how it reflects. Maybe we'll need to add some packages and build the code, run UI test. But moreover, we won't need something complex to implement the DevOps practices we have